this cataract case and the surgical part also. We'll try to understand what is about the extended depth of focus IOLs or ADOF lenses. And first, let us understand what is spherical abrasion. This short video will allow us to understand the spherical abrasions and how we can use them, or rather, the IOL manufacturing companies are actually using them to provide us with something known as continuous range of vision or augmented depth of focus or extended depth of focus. And let us see. There are few natural aberrations which are seen in a spherical lens, but nature has evolved over billions of years and provided us a solution to these aberrations so that we can have a very good vision. So a relaxed natural crystalline lens has some amount of negative spherical aberration, and this is actually equated to the positive spherical aberration of the cornea. So as a result, we have a nearly zero spherical aberration in the eye. And this has been proven by a publication which I mentioned here, that the crystalline lens has some amount of negative spherical aberration and cornea has some amount of positive spherical aberration. And as age advances, this ratio changes so that the eye starts having some amount of spherical aberration. For understanding how these extended depth of focus IOL they function, let us embark upon understanding what is spherical aberration. So as we can see here that a natural lens, rather a spherical lens will have some elements. If we can divide this lens into portions, we'll find that it is basically composed of prism and a flat slab. And as you can see that these rays which are passing through the periphery of the spherical lens are focused earlier than the rays which are passing through the central part, so that a point source of light is actually forming an image which is having the point source in center, but also a halo around it. And this is because of those unfocused rays, which when if the screen is kept here, so as you can see, this point is well focused, but these rays which are traveling will extend and will project an unfocused zone here, as we can see correspondingly to this area, so that we have a halo which is having some amount of diminishing brightness as we go from center to the periphery. And this is what happens in the image when you have positive spherical aberration. So one solution is that you make the central part more curved or having more power so that this also converges the light as good as the peripheral part. So now we have a situation where we have zero spherical aberration and this can be designed. And now we have a point source of light forming a point image. So here we have crystal clear image, but the downside is that if our screen is slightly moved anywhere here or here, so if it is moved anteriorly or posteriorly with relation to the lens, we find that this image is totally unfocused then. So this is a cost to pay when we have a rigid optical system with no spherical aberration. Now another approach can be that we have the central portion which is even more powered. That is, it is even more curved and having more converging power so that the central part rays are converging before the peripheral part rays. And now again, we'll have those halos, which is also known as a pod, rather limbs, just like amoeba will have limbs, so that is known as pod. And this process where you cause this this halo to vanish or to minimize is also known as apodization. However, we'll just focus on how this is going to help us. Now, what is happening is the central part is more converging. And we know that when we look for near objects, our pupil gets smaller, constricts, and then most of the rays are passing to the central part of the lens. So this is an arrangement which is already there. So if our central part is having more converging power, it will help in proving in focusing the light which is coming from near. So as a result, if our screen is rather our retina is focused for here, these rays are going to get defocused. And if our retina is something here, or rather we can also counter check that if our power is little off the correct mark, then we'll have some amount of halo, and this is known as negative spherical aberration. Now, how can we use this is because the central part is more converging, so it will be exposed when we are looking for near objects. And as a result, we have some amount of better focus of near objects because now this central portion is processing the incoming rays. So this is one design of IOL which is available, and this has similar kind of contour, and we'll just see in this surgery and the appearance of the IOL under the microscope light and also on the slit lamp, which will show us this central little bump. And now once we have understood that what this bump does, we'll appreciate the property of the lens better. And let's see. In the sense that the cataract has been removed, and now this is the point we are implanting the aforesaid IOL. And we'll just see how this IOL goes into the bag. And this is a routine activity where you use IOL dialer to put the trailing haptic into the bag. Now notice that there are few reflexes seen from the corneal surface and the IOL surface, and these are all very well known to us that they are also known as Purkinje images 1, 2, 3, 4. Out of these, the first image is very bright and it comes from the corneal surface. And then we have the second and the third. The third one is equally bright or nearly bright. As we can see here, at times we can see the reflection of the light from the anterior surface of the IOL, which is reflected as like a glassy reflex. And we'll just watch what is so unique about these IOLs. Now watch this portion where the anterior surface of the IOL is being reflected and we can see a small bump. This bump is what we were discussing in the presentation part, and we could see that the central part is having a more bump or a converging part, which will aid in providing us a better near vision. And the same bump can be viewed on a slit lamp photograph where we can see this bump. So this is how these lenses, they work. And this particular IOL which I'm talking about is in focus IOL from Appasamy Associates.